Have you ever wondered what if instead of writing your name on a registration form, you started writing in the language of Satan? Would that break the website? That's what we're doing today. Let's talk about something crucial: user input validation. Over the recent decades, this subject has caused some of the most catastrophic events in digital history. User input is most often the Trojan horse of web security. When a web app lets users submit data, whether it's a form, a comment, or a snippet of code, that input needs to be treated like a ticking time bomb. One famous example is the spectacular Equifax breach in 2017, one of the largest data breaches in history. And it all started with negligence to updating your software and a lack of proper input validation. The Equifax website used Apache struts to handle web requests, which is just another Java application. The team at Equifax were a little too comfy and apparently didn't update their software when a security patch came out for Apache struts. Now, since this patch was public, the attackers shifted their focus onto it and found a vulnerability which let them inject malicious input through an HTTP header. And because the server didn't properly sanitize or validate the input, attackers were able to execute their own commands, essentially turning the server into their playground. With this new access, attackers could install backdoors, move freely across the private network, and exfiltrate massive amounts of sensitive data, completely undetected for months. In the end, Equifax lost sensitive data belonging to 147 million people. Names, birth dates, social security numbers all exposed. Estimated 700 million in settlements. In the tech world, the word infrastructure usually refers to the fundamental design of how code will run and interact with itself. Much like in the real world, we see roads connecting people and fire stations being placed in strategic locations. Digital infrastructure connects servers to end users, and firewalls or security checks are placed in specific areas to protect networks. Because if someone decides to change the infrastructure or somehow take advantage of it, well, we're all in trouble. This next example is a practical case of what happens when input validation goes wrong. The site tries to help users by checking their Python code for syntax errors. But of course, similar to the YouTube comments section, there is always one person in 100 or 1,000 who will take it too far. And today, that person is me. This Capture the Flag challenge is made to break things in a safe environment. Doing this on a legit website will not end well. When we try entering Python code in here, everything seems fine, but if there's an error, it highlights the exact line where the syntax goes wrong. Seems pretty helpful, right? I can finally test my first ever script that I wrote in 2019, which was the game Battleship. It was only single player, and there was only one small ship to sink. You were given 10 guesses, and there are 25 spots of where the ship could be, so, you know, it's gambling with extra steps, and the house always wins with those odds. But if we were to change this working script and take away a parenthesis somewhere, the website would immediately tell us and show that there is a syntax error. So, being curious, let's look at what is happening under the hood. Let's open Burp Suite and see what kind of requests are being sent. This is the communication between us and the website servers. We first send a request with specific information. For example, I'm using this kind of browser, I want to receive things in English, and please check my Python code, here it is. In response, they send, yeah, you're all good, mate, nothing to worry about. So let's send them something to worry about. A Python script that has an error. How will they respond now? Well, they give away a bunch of information. Most of it useless and looks like crap, but let me explain it. It seems that the website is using ast.parse as a method to test our code that we send. You can see it processes the request.json, and this is the JSON that we're sending. At the end, they give the error description, which is, in line 1, the parentheses was never closed. And notice that they send back what was written on that line. You might be thinking, well, so what? Not a big deal. Until we see that the AST function, which tests our code, can take in multiple inputs, like the source, which is the code itself, but also file name, which presumably is set by default somewhere as the input text file. But what if we set that to the file where the server stores its sensitive information? We would like to know those secrets, it's only fair. So let's add a parameter, file name secret.py. We get a similar looking error, except this time the response is reading from the secret.py file. Because the syntax error is the same, the parentheses was never closed, but the contents are no longer there. So maybe this is the first line of the secret file. Let's try changing our code so the error occurs a couple of lines below. And sure enough, when we reach line 3, we can tell we are getting closer. Line by line we go, and on line 6 of the secret file, we find the flag. So what exactly did we do here? I mean, we made an error in our script, but told the website to give us the contents of the error from another file instead of the one we wrote in, which essentially gives us the ability to read any file in the infrastructure of the website. You can probably guess that as an end client, you're not supposed to have this kind of access. So how can the website avoid any unwanted break-ins? As many of you figured out, don't let the client input the file name as part of their JSON parameters, but also don't display so much information about the error if all you're showing on the page is a red line. When designing a website or any software really, you want to limit how much information you're giving to the end user, mostly to only what is useful or being asked of. The more information or functionality you have, the more possibilities you are creating for an attack. Of course, this isn't true for all scenarios, and your defense might be stronger in other places, which compensates for a mediocre backend design. Either way, thank you for watching. Same time next week. Stay safe.